The air entrance is designed to conduct incoming air to the compressor with a minimum energy loss resulting from drag or ram pressure loss. That is, the flow of air into the compressor should be free of turbulence to achieve maximum operating efficiency. Proper inlet design contributes materially to aircraft performance by increasing the ratio of compressor discharge pressure to duct inlet pressure. This is also referred to as the compressor pressure ratio. This ratio is the outlet pressure divided by the inlet pressure. The amount of air passing through the engine is dependent upon three factors. 1. The compressor speed in revolutions per minute. 2. The forward speed of the aircraft. And 3. The density of the ambient or surrounding air. Turbine inlet type is dictated by the type of gas turbine engine. A high bypass turbofan engine inlet is completely different from a turboprop or turboshaft inlet. Large gas turbine-powered aircraft almost always have a turbofan engine. The inlet on this type of engine is bolted to the front, or A-flange, of the engine. These engines are mounted on the wings, or nacelles, on the aft fuselage, and a few are in the vertical fin. Since on most modern turbofan engines the huge fan is the first part of the aircraft the incoming air comes into contact with, icing protection must be provided. This prevents chunks of ice from forming on the leading edge of the inlet, breaking loose and damaging the fan. Warm air is bled from the engine's compressor and is ducted through the inlet to prevent ice from forming. If inlet guide vanes are used to straighten the airflow, then they also have anti-icing air flowing through them. A typical turbofan inlet also contains some sound-reducing materials that absorb the fan noise and make the engine quieter. Turboprops and turboshafts can use an inlet screen to help filter out ice or debris from entering the engine. A deflector vane and a heated inlet lip are used to prevent ice or large chunks from entering the engine. On military aircraft, the divided entrance permits the use of very short ducts, with a resultant small pressure drop through skin friction. Military aircraft can fly at speeds above Mach 1, but the airflow through the engine must always stay below Mach 1. Supersonic airflow in the engine would destroy the engine. By using convergent and divergent shaped ducts, the airflow is controlled and dropped to subsonic speeds before entering the engine. Supersonic inlets are used to slow the incoming engine air to less than Mach 1 before it enters the engine.